Please help me in welcoming Dr. Kellyfast.
Well, thank you so much for having me back here again. I so enjoyed getting to give a talk back in March, and I spoke on planetary defense, finding asteroids before they find us, and I really gave the fire hose on that for those of you who were here. So this time I'm hoping to take it to a different level, looking at more just the fun side of things, looking at missions to small bodies, some things that are coming up and underway right now at NASA, and also some things looking at in the future. But I must say here, I just have to comment, you have an incredibly unique and amazing library and observatory facility here. It's just one of a kind, and you have an incredible staff here too. So I know that something like this, it's not just any one thing. I think it's the facility, it's the people who staff it, it's the people here who participate in these programs. So I think everybody here has really something to be proud of, and it's an honor to be back here to speak to you. So I am going to speak about small body missions, and if you saw the handouts in the back, there are brochures on planetary defense, and there's the NASA meatball sticker, and then there's a bunch of handouts on Pluto, mostly because we were out of other materials on other missions, and so it's kind of heavy on the Pluto, but everybody loves Pluto, so I hope you can enjoy that. But that mission is going to be involved in another encounter, and that's part of what I'm going to speak about today. But first, if you were watching the news, or maybe you were here watching today, or if you were watching online, you know that we had a Mars landing today. And that's a pretty big deal because, yeah, and it worked. We don't land on Mars very often. When we do, it's a tough thing. I mean, we're in terms of all of the space agencies, we're batting less than half. So in terms of success, trying to get to Mars or get to the surface. So even though I'm speaking on small bodies today, it would be really silly if I didn't say something about the mission that just landed on Mars. I mean, just a couple hours ago. And this mission is called InSight, and it would not be NASA if we didn't have a really tortured acronym. And so InSight represents the interior exploration using seismic investigations, geodesy, and heat transport. I don't know, what in the world is that? So, but really, it's a mission to study the interior of Mars, and there are ways you can do that without actually going down into the interior. It has a very sensitive seismometer on there that's going to measure any seismic activity on Mars. Mars isn't very seismically active, not even sure how much. It doesn't have plates moving around on the surface the way we do here on Earth. And so this mission will be able to measure if there's any seismic activity on Mars. It will also measure if there are impacts hitting Mars, and that does happen all the time. But those waves traveling through the Mars are modified by the interior, and so when this instrument measures it, it's a way of learning something about what's going on in the interior of Mars. There's also going to be a drill that's going to drill down into the surface to measure heat flow up from the interior of Mars. It's only going to go down about, oh goodness, I don't even have the number in my head. 16 feet. I'm always doing this like feet, meters. In science we work in metric system, and then when we speak to the public, we're supposed to go back into feet and all that. Thank you. But even though that's not very far on the surface, that's a way to measure how the heat is transported up through the crust and learn something more about the interior. And so the spacecraft I work with, the MAVEN mission at Mars, is looking at the upper atmosphere and how it interacts with the sun. InSight is looking at the interior. There are rovers on the surface and other orbiters. And so this is a chance to really learn about Mars from the interior to space. And if you had the TV on, this is the first image that came down from InSight. Now, it might look really awful, but this was exciting to the people who were seeing this come down. There's a dust cover on the camera, and so that's why it looks so awful, because there's material from the landing that's been splashed up on the cover. But if you see there on the top, you can see the horizon off in the distance. You can see that kind of pinkish sky because of dust lofted into the atmosphere. So This is just one of many to come, but it was certainly a relief to see this and know that, okay, it's made it and some things are working. And so it'll be a long time as things get all set up on the surface there and get the instruments all deployed and calibrated, but we'll see some cool science. Now, I dragged my parents to see the launch of InSight because this was the first planetary mission launched from Vandenberg. So this was out here in California. That was kind of unique, and I should have known better. I heard it gets foggy, so we all get together. We go to the launch. It's like middle of the night. They truck us out there and see the sky behind us. That's exactly what the launch looked like, too. We just all kind of stood there, and we could hear it, but we couldn't see anything. And since there have been a lot of animations showing about landing InSight on Mars, I chose a little different one that was, it's actually one of the non-NASA ones, one of the contractors. But just to give you an idea how you get something like this on the surface, it's very hard to land on Mars. Many missions have failed in trying to do that. And it also depends on how heavy the spacecraft is. It's hard enough landing a lander like InSight, which isn't a rover. The small rovers, they landed in these interesting airbag constructions, just dropped them on the surface. InSight uses a spacecraft body and landing system that was actually previously used on Mars, so that was a good thing. The Phoenix lander landed in the polar region of Mars and did studies up there for a period of time. And so this mission was the main part of it, the spacecraft structure, was based on that, on the Phoenix lander, but with very different science instruments and different science goals, a different location it was landing. But even though it was done before, it's still a scary thing. Mars's atmosphere is about 1% that of Earth, so there's not much atmosphere there, but there's still enough that as a spacecraft comes hurtling through the atmosphere, it's going to heat up, it's going to get warm, and so what you're seeing there is the heat shield protecting the rest of the spacecraft. And then once it's down far enough, these parachutes that can just deploy at high speeds deploy, and then the heat shield drops away, and inside that cone there is the InSight lander. Tucked up, so the legs have to deploy, so big relief when that happens. And then it's dropped, so it's the rest of the way as it heads to the surface, it's using little jets to keep it from falling faster, to slow it down and to land it on the surface gently. What was the comparison I heard? It was like I think I saw somebody write it out as a joke. They said it lands like the kiss of an inebriated butterfly. And so that's it. And once it's down there, it deploys solar panels, and it's going to take a while to deploy its instruments. I'm not going to keep playing this the whole time, but it's there, and you'll be hearing more and more over time. If you go to nasa.gov and look up InSight, you can continue to watch what happens over the next few months. So I'm going to move on from Mars because I came here to talk about small bodies, but we've got lots of good things going on throughout the solar system. So we were talking about Mars, and here's Earth orbit, but there's all this leftover stuff from the formation of the solar system. And you have asteroids, if you've heard of the asteroid belt, between the orbits of Mars and Jupiter. That's all of these yellow dots. There's also many dots, if you came to my talk before on planetary defense, there's a lot of asteroids that kind of come into Earth's neighborhood, and so those are the ones that we want to really keep an eye on. These little V's on here represent comets. There's comets flying through the solar system. And I'll talk a little later about further out in the solar system. But I want to focus on some of the asteroids that actually come close to Earth, but aren't anything that we're worried about, and so we can actually do fun science with them. But first of all, let me start with the asteroid belt, because we had a spacecraft that had been doing science at the two largest asteroids. I know some of the people are out here about Pluto's a planet or Pluto's not a planet, and we won't have cage fights over that or anything right now. But but the largest asteroid in the asteroid belt, Ceres, is actually considered a dwarf planet, also like Pluto, because of the definition. It's big enough to be round. It's going in orbit around the sun, and so it has a dwarf planet designation. And it had some interesting evidence of water on the surface here with these salty deposits, still trying to figure some of that out from the data. And then the largest asteroid, Vesta, after it explored Ceres, it actually left Ceres and went to see the next largest asteroid, or which is considered now the largest asteroid, Vesta. Well, that mission ended on October 31st. We knew it was going to run out of hydrazine propellant eventually. It had reached the end of the resources it had, and so it was just going to keep doing its mission until finally we stopped hearing from it because it would have run out of propellant and wouldn't be able to point at Earth anymore to transmit information back. And that just happened a couple weeks ago on Halloween. So we kept wondering about this, and we thought, okay, has this become a zombie mission on Halloween? And indeed it did. So Dawn completed its mission, but lots of good data from the asteroid belt, the main asteroid belt. But there's a lot of other asteroids out there, and this graphic represents asteroids visited by spacecraft, asteroids and comets. Comets are icy rocky bodies, icy dusty bodies that form tails when the sun heats the icy surface and blows that material off as it comes closer in the inner solar system, and I'll say something about a comet upcoming this year. But this graphic gives you an idea of the range of sizes of asteroids out there if you could put them all together for a family picture. And the ones I showed earlier are even bigger than these. But there are missions right now to these two asteroids here. The United States has a mission to the asteroid Bennu, and the Japanese have a mission to the asteroid Ryugu. And the operations are going on right now. And so I want to say a little bit about those. So the U.S. mission is actually approaching Bennu right now. Okay, another tortured acronym. It wouldn't be NASA if we didn't have that. OSIRIS-REx is the Origin, Spectral Interpretation, Resource Identification, Security, Regolith Explorer. And those all do mean things, trying to understand what Bennu is made of, looking at it from a resource point of view. If you were ever to send a spacecraft out there that actually made use of minerals that were in the body, what are these made of? What could you actually use? Security. Bennu is a near-Earth asteroid, so it's one we want to keep an eye on with other near-Earth asteroids, just to make sure none of them become an impact threat. Regolith is the dirt on the surface. So anyway, let's see some real pictures. Now, when you look through a telescope, like if Bennu came close enough and you could use the telescope out here during the period of time when it's positioned right, it would still look like a dot in the telescope. And that's fine, because you can learn something about the motion of an asteroid. From the motion, you could learn about its orbit. You can take a spectrum of it and learn something about what it's made of. You can do things from far away, but it's always nicer to get closer. When it's close enough for radar, if the asteroid passes close enough for radar and you can bounce radar off of it, you get a radar image. And a radar image is a little different from a real image of it, but you can take that and you can turn it into a shape model. So look at that shape model there. That's all we knew about the actual shape of Bennu until really recently. Now, this is an approach video from just a couple weeks ago, showing on approach to Bennu. This is what it looked like. And it looked a lot like that shape model, which should be expected, but it still surprised me because, scientists always say, oh, we've never seen anything like this before. And so it actually looked like we were expected from the shape models. So this is what that asteroid looks like close up. Now, the thing about OSIRIS-REx is it's a sample return mission. So it's not just going there to study Bennu, it's actually going to take a sample, the surface, and bring that back for analysis. But you look at this, look at all the boulders and everything all over there, which is really cool, but you think, okay, where's there a safe place to take a sample to make sure that we can actually get it and bring it back? So it's going to actually take quite a while to do the reconnaissance and study Bennu, and then eventually take that sample at a time when the orbits of the Earth and Bennu are such that you can send that sample return canister back. This is an animation showing how that sample will be acquired. It has a sample collector arm that will, they say it will kiss the surface of Bennu and retrieve that sample. So how does that work? So this is what that should look like. Compressed air is actually sent through that sampler mechanism, and it will shoot regolith, dirt, sand, up off the surface and end up in these capture canisters on the side. And so, and then from that, that material will be returned to Earth to analyze in the lab. Now you can find meteorites on the surface of the Earth, things that fell from space, and there's a lot of analysis that's done of those, but to be able to actually take a sample from a body that you know from a known population of asteroids from a particular orbit, you can understand so much more about the science, about why it is the way it is. So this is going to be very exciting. But at the same time, even ahead of this encounter that I'm showing, the Japanese space agency JAXA has their Hayabusa 2 spacecraft, also a sample return mission, operating at the near-Earth asteroid Ryugu. And here is one of their approach videos going toward Ryugu. And you can see the shadow of the spacecraft there with the sun behind it and the opposition effect of the glory. Now here's Ryugu. Ryugu is an even larger asteroid, but very similar in shape to Bennu. Similar situation where first it was observed from the Earth and it was targeted to be the destination for the mission. These images actually came before the OSIRIS-REx images because that mission reached its asteroid first. And look at, there's even more boulders. I mean, people are looking at that and saying, where's the regolith? I mean, where are they going to get a sample from? So it's been very interesting, and it had the people working on OSIRIS-REx wondering, okay, when we get to Bennu, are we going to find a good place to sample? Because with the spacecraft, I always tell kids in schools, you can't just go out and fix something. If something gets stuck, you just can't go up. Like with rovers, if you have a remote control car, you get stuck in your living room, you go pick it up, turn it around, get it out from under the couch or whatever. And you can't do that when it's roving on Mars, or you can't fix something if you get your collector arm stuck on a boulder on an asteroid. So you got to plan it out very well ahead of time. And so here's what the Japanese mission has some extras as part of their mission. In addition to getting to Ryugu, which it did, it also dropped some small satellites, little landers. I'm going to show some pictures from those in a second. And it's going to create an artificial crater on Bennu, so it's going to use an impactor to do that. And it's going to, after it finds the right place, it is going to touch down within the crater and get some samples from under the surface. So this way it's not just getting material on top that's been affected by space. And then it will also bring a canister back to Earth with the sample in it for analysis in the labs. So this is going to be really neat. Now they've got some really cool close-up pictures. Now the OSIRIS-REx spacecraft really doesn't get to Bennu until December 3rd, so it's still approaching. Those images I showed are still from far away. Hayabusa 2 mission has actually been close to and taken close-up images to Ryugu, actually doing some maneuvers where it has come in very close, gone back far away. And so the scale on here, like this is 1 meter, this is way close. And for any amateur geologists or retired geologists out there, folks are having a ball with this sort of thing. Just amazing. Here's another picture of one of these sections maneuvering in. So this little subsection here is blown up. I mean, so this is the surface of another world, and it's just amazing. But what was really cool, there were these two little landers called Minervas. They called them rovers, but they actually hopped on the surface. And this is one of the pictures from one of the hops on the surface of the asteroid. And so this was the first lander, the true lander on an asteroid ever. One of the U.S. missions near Shoemaker a number of years ago, went to an asteroid, and actually, once it was finished with its entire mission, it set down on the surface. It wasn't designed to do that, but it was the final thing to do with that mission. This was an actual lander designed for the surface, and we'll be seeing more and more as they roll up all that data together. Now, the Europeans also put a small rover on the spacecraft and sent that along called Mascot. And these are images from Hayabusa 2 showing Mascot being thrown out. I kind of picture it like coming out of some little Pez dispenser on the spacecraft. But this was another little hopper that was sent to the surface. But again, these kinds of close-up images of asteroids are really unprecedented because we can look at all of them from the ground, and it's very important to understand the whole population, the thousands and thousands of asteroids, but to get these close-up looks are just amazing. And it's going to target an area. It dropped a little target marker as part of a practice for when it's going to actually do its sample collection. And here again, you can see the shadow of the spacecraft on the surface. And it's kind of fun seeing a movie of the images as the spacecraft did one of these maneuvers, approaching the asteroid real close and backing off. Again, just trying to do things carefully, to do a whole lot of reconnaissance before deciding the next move. And so if you can kind of put the two of those to scale side by side, that other graphic I showed, they're real small compared to some of the even larger asteroids out there, but the two teams are actually communicating and coordinating because it'll be very helpful to compare what is learned from each of these missions, both in terms of operating, doing sample return operations, and then also the science, doing analysis of what's brought back from both of these missions. So it's been very exciting. So what about some other small body missions? Now, I had a lot of information back there on New Horizons because it happened to be what was in stock when I was getting some materials together to put in my suitcase and bring out here. You know when you take laminated things in your suitcase, security likes to open it up there, TSA. So because of all that stuff I brought out, TSA had to stop me and open up my suitcase and look. But the New Horizons mission, that was the one that went by Pluto. And you've seen some of the pictures there, and I'll show them again. But the thing is, there is out beyond, so earlier we were looking, here's Jupiter's orbit, here's Saturn's orbit, there's all these comets out here. Here's Uranus, here's Neptune, and here's Pluto's orbit way out here. Look at all these other dots out here. There's some more V's, comets, but there's all these other icy bodies that orbit way out at the orbit of Pluto and beyond. That's called the Kuiper belt. It was predicted to be out there, all this leftover material from the formation of the solar system, all these icy bodies, and over time, more and more of these have been found. So that's part of the reason why Pluto was demoted, because it turns out Pluto's not the only one of these out there. Pluto's one of the largest, but there's others that are quite large also. So the thing is, okay, you're going to fly something out to Pluto. You got to get it going really fast so you can actually get it out to Pluto. And it's just a flyby. You can't slow down and go into orbit. That's too hard when you're trying to fly something out there quickly. So you've done your mission. So what next? And so a search was done with telescopes on the ground and ultimately with the Hubble Space Telescope to find another target for the New Horizons mission. And but first of all, before we get to that, I just want to talk about how Pluto was found, because that was very difficult too. But this is the discovery image of Pluto. And it was just, these are all stars here, and it was just a little dot that was seen moving against the background of stars. It was part of a search for looking for a massive planet further out in the solar system. And yet Pluto was found by Clyde Tombaugh at the Lowell Observatory. And so, again, like with the asteroids, that's kind of what you see. You see a dot. Eventually, you have something like the Hubble Space Telescope, and you crank it up as best as you can, and still this is as good as you can do in terms of looking at the surface of something so far away. You kind of get some color variation, which is very important, but this is as good as you can do. Now, this animation shows sort of the stages of Pluto over the course of exploration of Pluto, starting from first telescope images, Hubble, and then all the way to New Horizons, approaching Pluto, and then finally there's that beautiful heart, and then finally getting really close-up images of the surface. So Pluto, through the years, finally, I mean, it was one of those things where you never knew what Pluto looked like, and then all of a sudden you know. And so, of course, just from a PR point of view, how fantastic was it that there was a heart on Pluto, and so everybody was just having so much fun with the hearts on Pluto. But it was amazing. But fantastic, amazing topography and geology on the surface, processes with ice and everything. And the data are going to be studied for years and years to come. And Pluto has a very large moon, Charon, and Charon was also imaged during that flyby. They're not really this close together, but at least for looking at it as a family portrait, here they are put together. So, but so much more on Pluto, flying by and finding out it still has this tenuous atmosphere, even though it's so far away in the solar system. There's enough heating that there's enough ice that's sublimated to form this tenuous atmosphere that's seen from Earth, but to get this kind of detail. And it was predicted that, because Pluto gets further away in its orbit over time and then comes back around again, but over so many years that was thought, you know what, by the time we send a spacecraft out there, that atmosphere is just going to be frozen out and it won't be there to study. And it was there, and so that's one of the mysteries too that continues to be unlocked on Pluto. And then just beautiful, beautiful close-up views of the surface. So, but what next then? Okay, we got a working spacecraft. Where can we send it? And it took the Hubble Space Telescope to finally identify small bodies. When they're discovered, they get designation. So it was discovered in 2014, and so at that time of year, the designation it got was 2014 MU69, and it was recently renamed Ultima Thule. So that's the destination, and they were pretty ambitious and went ahead and made a patch for the extended mission, Ultima Thule, with the shape already on there. And the reason was there have been observations done from the surface of the Earth. Even though you can't see Ultima Thule, it's just too small. The only way it was even found, discovered so that it could even be a target for the mission was with the Hubble Space Telescope. But when a small body passes in front of a star, and then the star dims because the small body blocks it, you can learn something about it. And there were many stations set up around the Earth to watch Ultima Thule occult a star in order to learn something about its shape. And when that happened, it was evident that it wasn't round. And so here's some of the things it could be. It could be a binary where it's actually two bodies, and it's just the way that we were looking at it at the time. It looked like they were together, but maybe it's a true binary, two objects instead of one. And there are other objects like this out in the Kuiper belt. Or maybe it's a contact binary. This is seen a lot in small bodies, in asteroids and in comets, where there's two bodies that are actually touching. Or maybe it's just kind of potato-shaped, which there's a lot of comets end up looking potato-shaped. So the thing is, we're going to find out on New Year's Day, the flyby is going to happen. So that's one of the nice holiday things coming up. We gave you a Mars landing. Now we're going to give you a look at another body out beyond the orbit of Pluto. So this will be the furthest body seen, and we'll see if they jumped the gun or not in making this mission patch. So we'll see what happens. And so finally, a couple of other small body missions coming up. These are in development, so they're not flying yet, but they were selected for development. They're being developed on the ground. One of them is called Lucy. It's going to be doing a survey of Jupiter-Trojan asteroids. Now, here's Jupiter orbiting the sun. And for any of the planets, there are these stable areas ahead of and behind the orbit that are stable gravitationally, and they tend to collect asteroids. There's only been, I think, one Earth Trojan ever found, but there are some Mars Trojan asteroids, and there are lots of Jupiter Trojan asteroids. And so the Lucy mission is going to do a many-year survey of a number of individual Trojan asteroids. And so that's in development. That would launch in 2021. And the other mission that is in development to go to small bodies is Psyche, which would be launched in 2022. This one is looking at one asteroid in particular, Psyche, which is thought to be the metallic leftovers of a planet that didn't fully form. And so this would have been the core of a planet that just didn't form and broke up. But when you form planets like on the Earth, you have this iron core, all the metal settles to the center, From ground-based work, it looks like this might have metallic properties, and so this mission was developed to go out and investigate Psyche and to see, is it really a metal core, and then to learn something about planet formation. So stay tuned, that one will be coming up. But now, since I did give you the fire hose on planetary defense last time I was here, and that involves the small bodies that affect us a little closer to home, I wanted to give an update on things that have happened since I last spoke out here in March. So getting into the more official side of things, this actually is getting more attention, not just at NASA, but on an interagency level, because there was direction to develop a national near-Earth object preparedness strategy and action plan. And this was released June of this year. And it really is a plan for the plan. It's not all the details of what would you do in each situation, but it was a chance to get different agencies together to look at what are the things that need to be done so that we would be ready if there is an asteroid that we need to be concerned about. And so the first step is finding them. And so some of the goals in that action plan would be to enhance NEO detection, characterization, and tracking capabilities to find them and to learn what they're made of. Improve modeling, predictions, and information integration. Okay, if you find them, you got to figure out, okay, where are they going to be in the future, and what effects might they have, if there is an impact. Develop technologies for NEO deflection and disruption. If you found a near-Earth object that was going to impact years or decades in the future, you could send a mission out there and you could deflect it, because you only have to deflect it a little bit for it to miss the Earth in the future. And so to try to get those technologies developed. Increase international cooperation on NEO preparation, because it's going to take international participation. That'd be very important. And to establish impact emergency procedures and action protocols. So again, just a plan for the plan, but there are agencies across the government that are involved in a working group starting to develop this. We've worked a lot with FEMA, doing exercises with them. But the thing is, it needs to be taken at the level, this is one of these low risk but high impact type events. And so a place like FEMA, they've got things they've got to deal with a whole lot more. Goodness, out here you got earthquakes, fires. We've experienced back east hurricanes, and we had little earthquakes. There's lots of things that are of higher priority, or at least of more immediate priority, but at least to start developing that plan from this plan for the plan, so that should it become an issue, it can be taken care of. And so another neat thing that happened, well, not neat, but it was at least reassuring to kind of get a gentle situation and see that, the system as we have it so far seems to work. There was an actual impact of an asteroid in June. Now, there's stuff hitting the Earth all the time. You see shooting stars, dust is hitting the Earth all the time. Sometimes you see a fireball. You'll see a real bright meteor. That's a bigger object. And that's kind of what the level that this was on. There was an asteroid that was discovered that was going to hit the Earth. And the thing is, that's only the third time that's ever happened, to actually find one ahead of time before it's going to hit. Because they're all very small and you don't see them until they're close anyway. This one was designated 2018 LA. Here's Earth's orbit, and here's 2018 LA's orbit, ahead of when its orbit and Earth's orbit came together, same place at the same time. And this happened on June 2nd. And it was discovered by the Catalina Sky Survey out in Arizona. And so here are the discovery images here. Again, just finding a dot that's moving against a starry background, going to the catalog and realizing, this isn't in the catalog, this is a new one, and getting enough information to calculate the orbit and realizing, okay, we need to watch for this. But it was less than 3 meters in size, so it's a small rock, so that's good. And it was only discovered 8 hours prior to impacting the Earth. And then there were additional observations made from the Atlas Observatory on Mauna Loa on the Big Island of Hawaii. So that's all you had in the 8 hours before impact. Now, let's see. Oh, here we go. So what about this? So first of all, The Minor Planet Center and JPL Center for Near-Earth Object Studies, they warned the Planetary Defense Coordination Office about this potential impact when they get the data in from the observatories and they do the orbit calculations. If there's something that's going to be an impactor in the short term, they send out a notification. And over at JPL, they do the real precise trajectory calculations and determine where something is going to impact, if there's an impact probability. And with those first few observations, here were the impact predictions, from the Atlantic Ocean across Africa, through the Indian Ocean, all the way out through North Australia. That was all that was known about where it would impact. But then when the additional observations from the Atlas Observatory were incorporated, here is what the impact prediction was. So that was before the extra observations were added. After more observations were added, the trajectory was more precise, and the predictions were that this thing was going to come in over the southern part of Africa. And sure enough, there was a bright meteor detected over Botswana at the right time that was predicted. And somebody's surveillance camera picked this thing up coming in, and so there it is up in the corner. Apparently one gentleman, he'd been visiting his neighbor and he was walking back to his house and he saw this happen. So he went back to his neighbor and said, "You might want to check your surveillance camera." And sure enough, there it was. And so this was a really amazing thing to see it in space, to know it was going to impact, and then to see it impact. Now, there's also government sensors that picked up the impact, and this is kind of a zoom in of a map of fireballs reported by government sensors. And sure enough, here's this one for that particular asteroid, 2018 LA. So it was detected by US government sensors, and also a Comprehensive Test Ban Treaty Organization infrasound, really low frequency sound sensors also detected the bolide. So multiple detections of it coming in. Now the thing is, this was much smaller than what NASA is tasked to warn about. So, because if it had been larger, we would have set up a notification on it. There is actually all the data on this were public anyway, but there's a notification procedure that there's a policy for that NASA would use in the case of something that we needed to warn about. But this was sort of a chance to exercise the system because it wasn't something that had to warn about. But it was a real world event. It was a chance to exercise the capabilities, and it kind of gave confidence that you could take the information and develop an impact prediction and get it about right. So at least if there is something that is of concern, a lot of the capabilities are in place to make that prediction. And this is only the third time in the 20-year history of NASA's NEO observations program that an object was discovered and an impact solution calculated prior to it actually hitting. So there were 3 warned impacts. There was one in 2008 called 2018 TC3, and that came in over Sudan, and meteorites were collected afterwards from that impact after it burned up and dropped meteorites in Sudan. 2014 AA, which was the first small body discovered in 2014, it impacted over the middle of the Atlantic Ocean. And that's the thing, we're covered by a lot of water, so the odds are, if something comes in, the odds are pretty high it's going to come in over water. And so the impact was predicted, but of course no meteorites collected following that. But then 2018 LA, impact over Botswana. And they were all discovered by the same astronomer out at the Catalina Sky Survey in Arizona, Richard Kowalski. And so I keep joking that we need to fire that guy so these things stop happening. But he's very good at what he does. And so, and that's why NASA has the Catalina Sky Survey and a number of other ground-based surveys surveying the skies to look for these things. So if there is something that we need to be concerned about, to warn about, or what have you, that can be done. So just a few other things coming up before I wrap up. Actually, this might be the last thing I wanted to point out before taking pictures. So this is a close approach we don't have to worry about. It's 30 lunar distances, so that's 30 times the distance from the Earth to the Moon. So not that close from an impact concern point of view at all. But for a science point of view, this is really cool. There's a comet called Comet 46P Wirtanen, because it was discovered by a gentleman named Wirtanen up at the at the University of California Observatory. And it's coming back around again. And this is a particularly close approach from a science point of view. And I'm always saying, at NASA, we send spacecraft out to our targets, like I was talking about the missions earlier. But this is a case where the target's coming to us. And so you can use ground-based observatories, like the Rancho Mirage Observatory, and look at this thing. It's not clear yet if it's going to be a naked eye object. Probably have to be really dark skies to see it as a naked eye object, but in binoculars and telescopes, even ones much smaller than the telescope here, you should be able to see that. And its close approach will be on December 16th, but it'll be visible all around that time period in December and into January. And so, oops, I'm sorry. And so this is around the time of close approach, but again, it's going to be plenty far away, and then it'll be heading off on its merry way. It's going to be bright for a comet because it's going to be close and it's large and it's an active comet. But still, comets, when you see them in the sky, it's one thing when you take a picture of them. They're fuzzy images. And so it'll be very diffuse and fuzzy, but still could be very spectacular in the telescope. And it's possible that even here, Eric will be pointing this telescope at Comet Wirtanen. But if you have your own telescope at home, you might want to do this also because we're hoping it'll be spectacular. I think it was David Levy who said, comets are like cats. They have tails and they do whatever they want. And that tends to be what they do. How active it's going to be, if it's going to have outburst and get even brighter, remains to be seen. But as it's on its way into our neighborhood and the sun is heating up the surface and it's creating this beautiful coma and it'll develop its beautiful tail, we'll see what it ends up doing. But this is sort of our holiday present because this is going to be happening in December. So we just landed a spacecraft on Mars. We have a Christmas comet coming by. And then on New Year's Day, we're going to see what one of the most distant objects in the solar system looks like. So it really is the season for big science from small packages. And I'm just going to go to just because it's cool, our logo that we have for planetary defense, because we're want to keep doing all the cool science, but also the applied planetary science, watching for small bodies before they find us. And so keeping on the watch, but trying to do the cool science along the way too. And that's what I have for you. Thank you.